Okay, so let's get into the periodic table. Let's learn about what's going on in the periodic table that we keep referring to and using so much throughout our past few lessons. Okay. The periodic table is a chart in which elements having similar chemical and physical properties are grouped together. So throughout the years, we've discovered all of these elements. Many scientists have discovered all of these elements, and they've noticed that there are trends amongst them where some of them act very similar to each other. So what they've done is they organize them into the periodic table based off of like qualities. So we're talking about chemical and physical properties. Things like density, hardness, color, what else was there? There's so many other things that we can classify these as. So there's so much more. So there's a lot of different properties that we can classify each element as to find their like qualities. On the periodic table, we can categorize the elements into three main groups: metals, nonmetals, and metalloids. Okay, so on our periodic table here, if anything in green, maybe I'll try to highlight her with green, there we go. Anything labeled in green is going to be a metal. So that's going to be all of these here. These are all of our metals. So there's a lot of metals on our periodic table. Feel free to label your own periodic table so that you remember where everything is. Okay, so there we have anything in green is a metal. Now metals are good conductors of heat and electricity, and all metals are solids at room temperature, with the exception of mercury, which is a liquid at room temperature. So all of these metals labeled in green are going to be solids except for mercury, which is way down here. Mercury is all the way down here. Okay? So next up we have the nonmetals. So nonmetals is anything in blue on our periodic table. So that's just this top corner up here. And then helium and hydrogen. Okay, so anything labeled in blue is a nonmetal. Nonmetals are poor conductors of heat and electricity. That's why we don't use carbon for the wiring in our houses. Okay, nonmetals are typically dull and colorless in their solid form, but nonmetals can be a mixture of many different phases at room temperature, such as a solid, a liquid, or a gas. For example, oxygen and nitrogen are typically gases at room temperature, whereas carbon is a solid at room temperature. Carbon is like graphite, the lead we find in our pencils, that's all carbon, so that's a solid. Whereas oxygen, nitrogen, those are gases, typically found in the air around us, in our atmosphere, and things like that. Okay, the last group are the metalloids. And metalloids have intermediate properties of both nonmetals and metals because they are the separators of the periodic table. They separate the nonmetals from the metals. So we call them the stair-step elements, which is anything in orange on our periodic table. And there are, eight metalloids on our periodic table. Let's zoom into those. Boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and, I can't even say that one, astatine? I don't know. It's a new one. That's one of our newer elements. So there are 7 of them. I don't know how to say that last one. Goodness. Okay. So we call them the stair step because they make a little stair step on our periodic table and separate our metals from our nonmetals. Typically, most periodic tables that you can find on the internet, if they're not in color, they have like a darker line that kind of separates the nonmetals from the metalloids. So it's typically starting between carbon and boron, but some of them sometimes have it here. So sometimes you'll see a dark line on your periodic table that shows you where the metalloids are in case you don't remember those exact elements. Okay, so they're sometimes separated by a line if they're not shown in color. Okay, so let's practice. Let's look at our periodic table. I have one on the screen, but you should pull yours out to make sure you can find all of these on your periodic table. And let's locate each element on the periodic table and classify it as a metal, which we said was green. Anything in green was a metal. Anything in blue was a non-metal, and anything in orange was a metalloid. So we first have titanium. Let's look at our periodic table. Let's look for titanium on here. Titanium is element number 22, 22 protons. It is in a green area, therefore it is a metal. Okay, next up is chlorine. Chlorine, let's find chlorine. Take a second, look on your periodic table or mine, and look for chlorine. Did you find it over here in the corner? Chlorine is element number 17. It's in the blue region, so it's a non-metal. Next up is krypton. Krypton. Let's look for krypton. Krypton's way over here in our last little column there. It's in blue, so it's a non-metal. Don't get it mixed up with potassium, which also has a K in it. Okay, potassium and krypton are definitely not the same thing. So krypton is a non-metal. Now we have palladium. Palladium. Let's look for palladium on here. Palladium. Palladium's down here in the middle of our periodic table, element number 46. Pd is its element symbol. It is in the green area, so it is a metal. Next up, we have arsenic. Arsenic is next. Let's take a look for arsenic. Maybe you remembered writing arsenic down in your lecture guide as one of the metalloids. So arsenic is right over here in orange. It is one of our stair-step elements, so it is a metalloid. Next we have cesium. Cesium. Let's look for cesium on our periodic table. Cesium's over in the corner here. Number 55, CS for cesium. It's in green, so it is a metal. Okay, you try the last two on your own. Use your periodic table to try to find selenium and osmium. Selenium's right next to arsenic over here. It's blue, so it's a nonmetal. And osmium is right in the middle of our periodic table, and it is a metal. So selenium is a nonmetal. Oops. And osmium is a metal. Okay. keep using your own periodic table, because sometimes having your own makes it a lot easier and a lot faster to find all the different elements. That's usually the bottleneck in a lot of problems, is finding where the actual element is that you need. Okay, so just get used to looking around your periodic table. Okay, so let's learn more about the periodic table. Boop, boop. Whoop. What's happening? Okay. Let's learn more about the periodic table. So, a vertical column is known as a group. So a vertical column, one of these guys, these are all columns, these are called a group. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We have 18 groups on the periodic table. Okay, we denote their group number at the very top of the column. Okay, we'll talk about what the different letters mean here in a second, but you can count them across as having 18 groups. A horizontal row is known as a period. So one of these guys is a period. Let's see, there we go, we'll box it up. So this is a period. Okay, and we start our period numbering by up here at hydrogen. So we have 1, 2, 3, 4, 5, 6, 7. These 2 rows down here come from this little cutout that you can kind of see right here. So they correspond with period 6 and period 7. They are not 8 and 9. They are just a cutout of our periodic table. So we have 7 periods and 18 groups. Now we define our groups as specific. We have different words that describe those groups because things that are in the same group have similar properties. Okay. So we have these letters on our periodic table. We have groups with A's and B's. Anything that's labeled with an A, we refer to as our main group elements. So groups 1 and 2 are labeled as 1 and 2A, and groups 13 through 18 have a special group label as group 3 through 8A. These are our main group elements. Okay, they are main group. Now because groups 3A through 8A are on the other side of the periodic table, separated by this middle area, they can be shown as either 3A or 13 or 4A or 14. You can refer to them as either one, okay? Either by their element, like their main group element value, which would be the A's, or by just the group number, which would be the values that are in the teens. This middle group, so group 3 through 11, which should be, that should be 3 through 12. 3 through 12, these are going to be your transition metals or transition elements. They are all metals, and they are known as transition metals because they transition us from one side of the periodic table to the other. So they're shorter, they don't have as many elements in their period or in their group, okay? So that's how we're able to see the main group elements, which are the taller columns, compared to the transition elements, which are the shorter columns. These have the letter of B. Okay, so we can have 3A and 3B, which is why this can sometimes get a little bit confusing, and we can always refer to our main group elements on the other side as either 3A or 13. So our transition metals, they have a B at the end of their group name. Okay, these bottom 2 rows, which I don't have a box around, These are called the lanthanides. The top one is the lanthanides. And the bottom one is called the actinides. We are not going to be using much of these elements in what we are doing in this course. They are typically more for inorganic chemistry, looking at radioactivity and things like that. So you have very radioactive elements down here, you know, uranium, thorium, cerium, names you probably have heard in reference to radioactivity. So we are not going to be looking at those very closely in this course. Okay, so most of our main group elements have special names. So group 1 or group 1A, these are the alkali metals. Note that hydrogen does not count, it is not in there. Okay, so hydrogen is not an alkali metal, it is blue, therefore it's a non-metal. So it can't be in a group called the alkali metals. So hydrogen is just an outlier for that group. So group 1A are the alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. Group 2 or group 2A, these are called the alkaline earth metals. Alkaline earth metals, and that's beryllium, magnesium, calcium, strontium, barium, and radium. So group 2 or group 2A are the alkaline earth metals. Group 16 or group 6A, again you can refer to it as either one. These are called the chalcogens. It's a weird name. Chalcogens. So that's oxygen, sulfur, selenium, tellurium, and polonium. We don't take that final metal into account because chalcogens are typically nonmetals or metalloids. So those are our chalcogens, group 6A or group 16. Group 17 or group 7A, these are called the halogens. The halogens: fluorine, chlorine, bromine, iodine. Those last two we don't typically see as halogens. We don't typically use them as halogens, so we'll ignore those for what we're doing in this course. So we're going to focus more closely and use more often fluorine, chlorine, bromine, and iodine. Our last group are the noble gases. So that's group 18 or group 8A. So that's helium, neon, argon, krypton, xenon, and radon. Okay, these are our noble gases. So their name alone tells us that these are gases. Okay, so let's practice. We just want to be able to find where these elements are on the periodic table and then relate that to what grouping they're in, what period, what group, everything like that. So this first one is asking us about an alkali metal. So alkali metals are group 1A. And we're looking for the alkali metal in period 4. So we have 1, 2, 3, 4, 5, 6, 7. So there's our period numbers. So we're looking for group 1A, number 4. So that is potassium. Okay, or potassium. Let's see. We're now looking for a second row element in group 7A. So here's 7A over here. 7A doesn't have a 1, so we're starting at 2. So here's our second row. 7A, there we go. It's fluorine. So we're right here. Second row, 7A. That's fluorine. F-L-U-O-R-I-N-E. Fluorine. Now we're looking for a noble gas in the third period. So a noble gas, that's group 8A. in third period. 1, 2, 3. That one's going to be argon. A-R, argon. Okay, so what I want you to do is pause the video and try the last 3 on your own. Look for the last 3 elements that we're looking for, either on my periodic table here or on the periodic table that you have. For D, I got strontium. For E, I got zinc. And for F, I got, let's see, transition metal, where is that? Niobium, NB. Niobium. Okay, so we have strontium. That is a 2A group, period 5. There we go. And then we have transition metal in group 12, period 4. Or group 12. And our last one is transition metal group 5, period 5. There we go, and that's niobium.